So we brought an amazing group of people here. We have people from large studios, small studios, people that have worked at large studios and small studios, et cetera. I'm going to briefly talk about each of the sponsors. We're very proud of the fact that, at least at the summit, this is a very engineering-only community. And if business people find out that a bunch of engineers are in a room, this place would be like half BD people, I guarantee you. So it's helpful for this to be a safe place for those conversations to happen. So I do want to talk about the sponsors because this stuff needs to be funded somehow by people. But even though they sponsor, many of their business people can't show up. So yeah, so as someone that obviously is working on tools for games, I'm obviously passionate about that. That's what I'm spending my time doing. And obviously, I'm a fan of other people that are committed to making game development easier. Each of the partners that is sponsoring this are folks that we have worked very deeply with. So first off, AWS. I don't know that I need to get a lot into AWS. You all know AWS, I think, hopefully. Pragma sits on top of AWS. We're really thankful that we get to work with them. Hathora they do server orchestration. Many of our studios that we work with are using Hathora today. They're just delightful to get set up and use. If you guys haven't gotten a chance to check out their platform, you absolutely should. Many of our launches this year has been in partnership with them. We're really thankful that we get to work with them. Mod.io, they're the leading UGC solution. We push anyone that's interested in UGC stuff to them. They've done more than 200 games, 850 million downloads. So they know what they're doing when it comes to UGC stuff. Unity Gaming Services, we work with Vivox a lot as well, and obviously, I'm sure lots of you guys have interacted with Vivox. So probably don't need to get that much into what that is, but voice, chat, toxicity, anti-toxicity, I should say. Toxic people at Vivox. And then last but not least, Pragma. We're a backend engine. We call ourselves an engine because we're sort of a source-first product that's meant to support customizations through plugins, extensions. We kind of believe that it's very difficult to make an online game. These are creative endeavors, and we want to allow engineers to express themselves through writing their own services. We're a fully managed service. We support features like accounts, social, matchmaking, player data, live metrics, those kinds of things. And we got a lot of studios that work with us that are here. If you're interested in the real truth of working with Pragma, I'd probably talk with them versus Pragma people, maybe. All right, a few other things. One, I think I mentioned, we do these houses at GDC and Gamescom. We announce those things on Discord, so if you're not on the Discord already, come to me. We should be posting that. We should have a post follow-up email with that Discord community link. We'll have a post-event survey that's sent around after this event. This helps us figure out like roundtable topics for next year, things that you guys hated and liked, things like that. Yeah, okay, let me intro John and Chris, and they will get going on the first talk. All right, John Shiring, better known as Slothy, very recognizable with the Mohawk. I don't know when I first got to know John, but maybe it was through Drew, maybe. But John's shipped a bunch of small indie games, Call of Duty 2, multiplayer, split screen, back when split screen was there, matchmaking on Xbox 360, Modern Warfare. This is the only full-time multiplayer engineer. He was the only full-time multiplayer engineer for the game. Person. Yeah. There's going to be more stories here, so I'm not going to get into as many of the details, but yeah, John's done some amazing, crazy things. Modern Warfare 2, Respawn with Titanfall 1 and 2, some of my favorites. Apex, which is what I'm addicted to now and still play. So yeah, just a few small games that no one's ever heard of. And introing Chris. Chris is the CTO, head of product, head of tech at Pragma. He built League of Legends matchmaking from scratch while it launched and became the biggest game in the world, 15 million CCU, 100 million monthly actives. And then he was the tech lead for player behavior, the anti-toxicity team, which is really his passion. And if you get him in a room, he'll talk your ear off about positive social interactions in games. Then he led the anti-cheat team at Riot, helping build Vanguard for Valorant. Also consulted for Epic on Epic Online Services. And yeah, it's obviously at Riot leading tech and product. So they're going to talk about all things online games. And yeah, let's give them a round of applause. And
Hi, everybody. It's good to be here. Thanks for being here either for the first time or coming back. Yeah, we're just going to talk about shipping games. And Slothy and I have been hanging out a bit, and I was hearing all the war stories and the fun and the excitement. And I just thought it'd be nice to kind of talk about the evolution of what it means to build online from the early days and the hard days of building it all yourself from scratch and just kind of walking through that journey together. So that's kind of what I was setting up. So without further ado, so before Call of Duty and Infinity Ward, you had your kind of break into games was on a smaller team. So I just want to hear, like, just kind of talk a little bit about what was that to join, get into games in the first place, what that team would look like. It was a smaller, endeavor, and yeah.
So there we go. My first game was this game that shipped in 2003, multiplayer-only game called Savage. And it was a strange game. It was a hybrid of RTS and FPS. So each team had one player that was playing the commander, that was playing an RTS game. And then it was a combination of AI and real players who were playing an FPS on that team. It's a little ahead of its time for 2003. The total team was 7 people. And it was funded by some millionaire guy. So I was just getting a salary to make video games, and I was pretty happy about that. We found, like, when we went to go try to get anyone to cover our game, they said, like, if you don't have a publisher, we're not going to write an article about you. So then we made a publisher and then published the only game, which was ours. And then suddenly we got, like, on GameSpot and all those things. And so it was quite an experience. And when it shipped, I think we hit, like, 35,000 concurrent. And so just for like a blip, and then it kind of died off. It was such a hardcore game. So after that, I kind of felt like I had won the indie lottery to make a game that anyone had ever played. So I quit because I didn't want to try to win the lottery a second time with 7 people. So that's where I went to Namco Home Tech for 6 months, left there and joined Infinity Ward in 2004.
So what was the tech stack, and both on the game engine side, but also network side? Like, what was going on in that era?
And so on Savage, you mean?
Yeah, on Savage. Yeah.
Savage was a homemade engine, and it was a server browser. And so we were doing the master server that would list all the things, and you could filter and sort and join games. That was pretty normal. I know I made it. I integrated with All Seeing Eye. That was the tech back then. Was you could do that, and it worked okay. Like, I think we had 64 player servers because it was all dedicated servers, a beefy Celeron or whatever.
Yeah, yeah. So and then in terms of the game networking stack, what did that look like with the dedicated servers? And
it was client server, which I did not work on. I was working on a lot of the UI and RTS part and AI and some of the FPS stuff, but I was kind of I was very junior and I didn't really know what I was doing. And I worked with this genius programmer who really showed me just how smart some people are and just how you get to that point where you get this dream job and you suddenly realize that you suck and you better shut up and learn and not let everyone know how much you suck. So that's kind of what I tried to do. I don't know how successfully, but I learned a lot on that first game. But it was it was a 100% custom code base with 3 coders. And I ported it to Linux. So we shipped on a disk with both Linux and Windows support. One of the only games I think that ever was stupid enough to do that.
Should have just waited for the Steam Deck. Yeah, it would have been a little easier. Yeah, but that's one of the things I wanted to set up with that kind of like background and history of just like from scratch building it all is kind of the evolution that we're going to walk through in terms of your journey and just like that kind of transition over time of what it means to work on online. So let's head to Infinity Ward and just talk a little bit about like both how you got there, but also just what are the dynamics of the studio at that time, team size, and just like what was the shape?
So when I joined Infinity Ward, I think I was employee 36. It was very small, and they just shipped Call of Duty 1. And that was why I joined, because Call of Duty 1 was incredible. And they hired me because I had worked on a multiplayer game. And they wanted someone to deal with multiplayer, because they were really single-player focused for fair reasons. And so I joined, and right around that same time, Microsoft was disclosing the Xbox 360. And Call of Duty 1 was PC only. So this was Infinity Ward's first shot at doing a console game. And so I went to the disclosure. There's fun stuff at that one. And then I got started on bringing the game to console. There were other engineers who did a lot of the real bootstrapping work to get us there and rendering work, because I think we had to move to DX9 from DX7 or something. I don't remember that era exactly which DX we were on. But I added split screen support. I made it work with all the session stuff that Xbox had back then, and did all the online work. And that went well. And so I kind of kept owning more and more. And so at one point I asked the studio head, Jason West, of like, what is the boundaries of what I own? And he said, everything inside the multiplayer executable is yours. Everything inside the single player executable is not. And so back then, as I said, they were very single player focused. So on that game, I think I was probably one of a few people who worked on multiplayer. Yeah, and the game shipped, and it was broken. And I learned a first lesson there. And I thought I'd like totally fucked up. Like I thought it was like, this is my big chance to like work on this big game, and it fell over. And yeah, that wasn't the end of my career though.
So I guess I want to take like a little sidecar into like split screen, because it's something I remember fondly. And even as I was like reading through the list of stuff, I was like, I remember playing Call of Duty split screen. I was like, oh, this is so useful because I could get back together with some buddies. But one, I mean, we don't really have that anymore. And I guess I'm curious about what the stack was like working on local multiplayer versus online multiplayer, and like how much collision was that, just at even a coding level, but also just like prioritization of like, again, today nobody's going to fund working on split screen, but like, I guess I'm just curious to think about local multiplayer versus online.
So we were both. You could play split screen online, I'm pretty sure. It's been a while. But you could also do private match with your friends. And that was where like a lot of people would just do split screen, on a couch with 4 people. There was a lot of work to make to hit frame rate. So we were trying to be 60. I don't know whether split screen on COD 2 was actually 60. I think it was probably a very rough 60. But we had to do a lot of optimizations to make it work. And I think ultimately those are really good optimizations to get, because it helps you optimize your client CPU and a lot of rendering settings that really help on min spec and stuff like that. But yeah, we had to support both. Back then, it was, Infinity Ward started with Quake 3 Arena, and in 2004 was when Robert Field threaded off the server. So you had a client thread and a server thread. And so the server could do its own thing with 4 players. It was okay on an Xbox. Xbox is the one that was with the harder work than PC. Actually, we didn't do split screen on PC. So, and then we had to do 4 clients and threaded that out, and we were fairly efficient at using all the cores on the 360.
Yeah, cool. And then you mentioned launch hurt. So like, what happened? What was going on?
So I was really looking at Halo, because that was like, this is the era where like a multiplayer game on a console was still pretty new. And a lot of games try to do a server browser, and it's just awful. This is like, 480i. Text is very hard to read. Sorting a list and trying to grab something in it is just not a good experience on a TV. And so I wanted to do playlists and automatic, spinning up servers on a player console and letting people connect to it. And so we had to do NAT traversal and bandwidth tests, and getting all that right was hard. And what undid me was and this is, I'm not blaming id. There was a setting that said if you're player hosted, this must be a LAN game. So I can take the Delta buffer and cut it down to 2 megabytes. And for us, it was not a LAN game. We were doing player hosted over the internet. But when we play tested, everyone was in LA. And so the latency was pretty good. And so during playtesting, it worked fine. I think once or twice we hit the bug that happened a lot at launch, but we weren't able to figure it out. And so it seemed like an odd case where some player was hosting and their hosting was bad. But the end effect was when the Delta buffer is low, when the server would try to build snapshots, it would run out of space of comparing what they knew about and what they needed to know about. And when that Delta buffer ran out, it would send every entity in the world. And so what you would see when it launched is the game would be running great, and then all of a sudden it would freeze, and then you'd get like 2 FPS world updates. And voice chat worked fine because that wasn't using the Delta buffer, so everyone would just be talking to each other about how bad the game felt and how the developers suck. And they found a picture of me and put that on the internet and said this is the guy's fault. And so that was a quick intro in working on multiplayer. And then we fixed it in a patch eventually, but it taught us internally we had to do like lag switches and get like ISDN lines into the building so that we were testing something that was a little more aggressive than testing on a LAN. So it was a helpful step, although very painful for me.
Yeah, that's one of the things I want to explore when we get a little deeper down the story chain, but is talking about like testing and just the dynamics of, in a larger game team, you oftentimes have dedicated front-end team, dedicated back-end team, and then you get all this like handshaking. And I both want to talk a little bit about, early days you were kind of doing it pretty end-to-end, but I want to explore that a little bit further as we get deeper.
Before we get off Call of Duty 2, I have a quick story. I was in my apartment in Sherman Oaks, and my phone on the wall rang, and I answered it, and a woman said, "Do you know why Xbox Live is down right now?" And I said, "No." And she said, "Okay, thanks," and hung up. And I was like, oh shit, I have no idea what's happening, but I'm in trouble. So I think we broke Halo in 2005 because not only did Call of Duty 2 have the Delta buffer bug, but we also had a different thing that took down Xbox Live. And that thing was, this is in the era where you had to do LSP. I don't know if anyone remembers LSP. Quite the fun times. You had to run a Microsoft daemon on a special version of Windows Server if you wanted a console to be able to send a packet to a PC. And we were doing some like error logging and other stuff because I wanted to see how the game was going. And the LSP server in its docs said that it could handle 256,000 players per instance. In reality, it could handle 64,000 players per instance. And so when they provisioned all those LSP servers, they provisioned enough to handle far beyond the concurrency we would see, but not far beyond the concurrency we would see at 64,000 players per instance. And so the game was continually asking for a list of LSP servers to connect to and then trying to connect to it. And what happened is Xbox came back to me and said, "You're calling it too often." And I looked at the code and was like, "It looks fine. Like, I don't see any obvious problem. We're calling it." Then we iterate the servers and connect to one, and we know there's servers to connect to. Who cares? And after like 2 weeks, they came back and said, "You're calling it about 15 times a second." And I went, "Oh, that kind of too much. Okay, now I know what the problem is." And then we solved that we needed to run more LSP servers. But yeah, so my first game, I took down other people's games, and my game was broken at Infinity Ward.
That's a fun one. It's not the same example, but we were at PopCap Games doing like early, Facebook mobile stuff, and we shipped a game binary that is like Flash based, and we were using Akamai, I think, one of the CDNs to push it out. But there was a bug in the literal URL of the game asset to hit the CDN, and so we basically pushed a DDoS attack on the CDN, and we took it down. And they were supporting like a massive, like tens of thousands of other companies, and we got a phone call too, so there's always fun ways to.
I still don't know where she got my phone number from.
That's wild. And that's hilarious. Yeah, that's wild. All right, so let's get into a little bit like Modern Warfare 1 and 2, but like, I think, I always go back like skill-based matchmaking versus lobby browsers is something that I almost forgot all about, even though like a lot of my early gaming life was like, StarCraft browsers, Counter-Strike. So I guess as we get further into the Call of Duty series, I guess what was happening at that time in terms of, again, there's consoles are growing and maturing, but I guess like what was the kind of sequencing of growing from, well, I guess I wanted to say growing from building it all yourself to having more of a team, but I don't know that you got much of a team around you at this point in time. So.
Yeah, this is something that I think is unusual still. The total dev team for Call of Duty 2 was about 65. And then we went all the way up to about like 85 or 90 on Modern Warfare 2. And so, there's like 11 to 13 engineers total. And so yeah, that's always been kind of a normal team size for me. I know that is not a normal team size anymore, but.
Yeah, so what are the dynamics of like, I've spent a lot of time working on much larger teams where I got to negotiate with like 4 different groups before getting anything done. So I guess like, do you feel like that improved your ability to execute, and especially with respect to quality and testing, because it's a lot harder to test online as you're already talking about. So like, I guess what was the feedback loop, especially the one I always think about is between the game team and the online team, or in this case, like you and like your other engineering colleagues.
So yeah, I would talk to coders about, all the technical side of what threads are going to run what and all this stuff. But mostly I would talk to designers about like, I wasn't that great at it back then, but like trying to figure out what they wanted to do, of like, how do you want matchmaking to work? How many playlists are we going to do? And trying to like fight over, you probably don't want 13 playlists, And so like, I was still kind of working all that out of like, I know it's on me to go build all this stuff so we can ship in 18 months, but like, I'm not really sure what they want. They don't really know because this is all kind of brand new. And so like trying to figure out how to ask the right questions to get at like how to design this thing is something I started doing then, but I was kind of just off on my own building stuff, like the playlist system and the matchmaker and the skill system and all that kind of stuff. I was just sort of doing, and I wasn't talking to design enough, but I would talk to them more than coders.
So then another kind of thing is like pretty like pre-AWS or cloud. So what were you doing for literal like DevOps or orchestration? Like where were you hosting your servers? And
so we used, well, I think, so going back to Call of Duty 1 and 2, the master server was like a PC running in the office. And so like, sometimes like word would come in that like the server browsers everywhere in the world stopped working and they'd go like restart the master server and like it would be fixed again. So going from that to like, hey, let's try to find out if there's any errors happening on the live game. And then I had a server that was collecting that data. And then all the dedicated servers were fan run or player run, whatever you want to call it. And that was going into Modern Warfare 1, where we, obviously I'd done player hosted on console, but we were pushing more into player hosted because the flow is so much easier and we didn't have weird moderators doing weird things on our dedicated servers. And there's a lot of benefits to it, although I also appreciate that people miss the server browser days too. So as far as infrastructure goes, we're still really reliant on people running servers that weren't crap, and it was inconsistent, but not as inconsistent as player-hosted was. So on Modern Warfare 1, I think it was Modern Warfare 2, we added server migration. So on Modern Warfare 1, we were kind of hoping that whoever ended up being picked to run the server for the whole match would stick around for the whole match, which was a bad assumption. And that like their roommate, excuse me, wouldn't fire up BitTorrent. That was the other thing. It's like, we do our bandwidth test and be like, they have great bandwidth. And then a minute later, we didn't really have a code path to handle, like they don't have great bandwidth anymore. And so matches would be inconsistent quality, as I said, but like in a really frustrating way where it's like you play 3 matches with the same people and it's bad sometimes and good sometimes. And then if you leave that and search again, it might be great. And so there was no real rhyme or reason to it. There was nothing players could do to make sure they were going to have a good experience. And obviously, when you're playing a sweaty game and trying to win, that's a really bad setup. It's like, sometimes we're going to betray you, and sometimes we'll deliver the experience that you thought you were buying.
So what'd you do for the server migration? Because that's pretty technically sophisticated. You got to coordinate and get everyone on, and like what is literally happening for players as you're trying to hand off.
So Andrew Wong, who is now at Supergiant working on Hades, wrote a multiplayer save game system. So he took our single player saves, made it work in multiplayer. The server, the current server, would do a save game and then send it peer-to-peer to the next server, which would load the save game, and all the players would reconnect to them. So it was reliant on the current server being alive. If the server just like disconnected, there was nothing to migrate. It would just fall down. But if we are in the situation where like their internet connection went to shit, everyone's lagging out, it would get triggered, and we would do that code path. Now, writing the heuristics to figure out how bad is bad enough to migrate and how long should we wait to see if it gets better is really hard. And so there was definitely a lot of like getting host migration in dev in the middle of a match, and people were like, why did that happen? And then we had to go look into, okay, what triggered it? How do we make it not overzealous about doing this? Because if you just have a match where it just continually migrates around, the migration took, 15 to 20 seconds. So like for that, you would get a pause screen that's like, server migrating, and you'd sit and wait, and then it would be like unpaused, hopefully. And it worked pretty well, and it definitely worked better than Modern Warfare 1 when we didn't have host migration, and players hated it a lot more.
They hated the migration?
Yeah, because now you would see,
You'd see it.
Yeah, instead of just like server disconnection lost or quitting out, you would see like in the middle of a match, you'd get this big annoying screen that would be there, and then it would just go away and be like, all right, now you can keep playing. So the experience was objectively better, but subjectively it was worse.
Yeah, I think maybe like if the game disconnects, then like it's just like, well, the world hates me. I got DC'd. But then like this telling people you're migrating the server is basically telling them we're doing this on purpose to you. So the pain you can direct directly at those devs.
Yeah, it didn't solve the bad experience. Like we were still at a maybe even more frequent rate having crappy connections. Mm-hmm. It would just try to fix it, and it was like a reroll. Like, let's see if this guy is going to have a decent connection. And so like we weren't really solving the core problem. We were just sort of like trying to stop the matches from ending. Which is sort of a debatable design goal.
Yeah, that's an interesting one. And just thinking about, you mentioned the heuristics of like deciding when it's bad enough. And I feel like you always get these like boundary problems where if you're too aggressive, then you start doing it all the time. If you're too loose, then it's like, hey, it's been shit forever. Why aren't you triggering this? So like, what'd you do to kind of test and optimize some of those decisions? I mean, you mentioned just having to experiment. Was all kind of guess and check to like find the right value?
Yeah, it's one of those things where like you get it so it feels okay and you're limited testing, and then you ship it, and if no one complains too much, then you never want to touch it again. And so it's now locked in at whatever settings were last tried.
Yeah, that's. I'm not going to digress. I want to talk about the whole hysteresis. It's like the thermometer problem. Of, like you don't want your heater turning off and on again, so you always have to like be careful that you actually like give a little room. Like maybe you get onto the new server and it might be choppy at first, but you probably don't want to immediately trigger another one of those transitions. Yeah. Yeah, so I guess, clearly, as you just laid it out, like there's a lot of stress and kind of turmoil as you guys are getting going. So just mechanically, as you guys are laying ground, you guys, started with, it was Source Engine, right? And as far as...
Yeah, Portal 2 is what we started with.
So how did that kind of come about as far as the tech stack?
First, Insomniac gave us their old engine, and we used that for a year. Then we scrapped that and moved to Portal 2, because for about a year, our design team was fairly unable to work. And so we had just the most amazing array of paper designs you've ever seen. And after a year, there was like, hey, what the fuck? Like, you can't, like, I'm tired of sitting around watching coders figure out how to like make this engine work. So then we switched to Portal 2 and threw away everything we had written so far. And that's where design like just got going. They just were able to use, the editor and make levels and try things. Oh. Hello? Okay. But Portal 2 is not an engine that you would choose to render big outdoor scenes. And there's this kind of false belief that the Source engine is just kind of fast. It's just do whatever you want. It'll just render great. But we had to do a lot of work because Portal is mostly, indoors with a doorway to go to another room. And Titanfall was not big open world.
Can we get a mic swap? Here, take mine.
Here, do you want this one? Finally, it's just me talking.
Okay.
So we had to do a lot of work there, and again, we had to port it to a new console. So we were like in that Xbox One launch window. We shipped in like March, but the Xbox One launch was like so rough that any game that shipped in the first 6 months was kind of barely getting through as if a launch title. And we had to do a new renderer again. We had to do new audio system, all kinds of stuff. So it was once again back in that pattern of like huge amount of engineering work just to get the game to run on this box instead of that box. And I worked on a bunch of that. Other people did as well. And at the same time, I went in going like, well, since it's source, we know it's going to have that like id netcode. I don't have to do a lot of work there. And I found that that was not true. So I was also rewriting the netcode. That was the first step of rewriting the netcode. And then on Titanfall 2, we had the second step of rewriting the netcode. But there was a lot of engineering work on that. And we had to do our own party system and all the Xbox APIs that were a nightmare to work with. Sorry, anyone who worked at Xbox then. It was a nightmare.
Okay, yeah, small tangent on that front. It was actually really interesting. I was doing some work with Epic, working on some of the early kind of EOS ideation, and we were analyzing different APIs, and there was the achievement system, and we were looking at all the different platforms. And there were two versions of the Xbox APIs, and the one was like the opinionated, like DSL, very configurable, very customizable, and it had all sorts of different machinations. And then it was like the one that was published 3 years later, literally was a single API call that said unlock achievement. And they're just like, you do the logic and just call us, because basically they found that just keeping it simple was a good way to start. So I thought that was kind of just a funny lesson in like making sure you connect with the actual use case.
My favorite achievement thing was they had not thought about what to do with testing achievements, so there's no way to take an achievement away. So if you wanted to test the achievements, you had to make a new account, play through the game to get all the achievements, and if you wanted to do it again, you had to make a new account and earn all the achievements. You couldn't just like turn it back off and then test your logic to re-trigger it. It's one that's like when you're only thinking about what you need for production and you don't think about what you might need for dev.
Yeah, so I guess I wanted to kind of rewind back to, so you guys are, took over source license, you're rebuilding a lot of the kind of underlying tech. In terms of, this is something we talked to a lot about with studios today, which is there's the find the fun of the like pure gameplay and just making a good video game. And that is, turns out, pretty difficult. And then there's the sequencing of like, well, when do I start working on the online features? When do I start working on the multiplayer features? Obviously for like a heavily multiplayer game, I imagine you're gonna start early, but what is the kind of development priorities in terms of online early iteration playtest inside the office versus we need to actually get an online test going, and how is the kind of flow of development priorities?
You mean what did we do then, or like what do I believe in today?
Both.
Okay. So what we did then, so how do I not digress for 5 minutes here? We used this thing that Xbox made called Thunderhead, which was their sort of hosting game servers on Azure. And some of that was from me going to Xbox and saying, you have to solve this problem. Like, it's really holding back games. Coming from my experience with host migration in Call of Duty and player hosted, I could see that like the problem we needed to solve was the quality of experience and the consistency of the experience. Every match should feel as good as the last one, whether or not you're right next to a data center or 70 milliseconds away. And so I went to them and said, we have to solve this thing. I know it's going to be expensive. We have to figure out how to make it not expensive. And they spun up this project. So as I said, Titanfall 1 shipped in March of 2014. It had a beta in February of 2014. The first time I played a match on Thunderhead servers was late December of 2013. We went the whole way waiting for everyone to get ready for, like, it's almost done, and then finally it was there and we had to start using it. So from trying it the first time to shipping something was 2 months. We tested on dedicated servers in an office, and we did, you can sort of see all the same problems of Call of Duty 2, of you're testing with no latency. So we had like fake lag settings and things like that, but you really need, not just emulation, but really trying out weird consumer connections and seeing all the quirks that really come with that. So we did not do that, and we survived it on Titanfall 1. Like, we got away with it. The game worked pretty well at launch.
Nice. Okay, so what should you have done?
Well, what we're doing, sorry, we're jumping ahead a little bit. I work at a studio called Gravity Well. What we're doing at Gravity Well was the first thing I did is to stand up dedicated servers running on a remote server in a data center with matchmaking so that we can go play. And so all of our play tests are happening on servers that are, we upload a build somewhere, it gets distributed out, it gets spun up, and you connect to it. So I'm trying to do it really like the right way from the start so that there is no mechanism for doing all right, that stuff's broken, why don't we just test on the LAN? And some of that is because we're a remote studio, so there is no LAN. So it's a really helpful forcing function there of like, we're gonna have people testing from Australia and France and Canada, so let's make sure we're really experiencing what's gonna happen when they do that.
And do you think, does that kind of hit development velocity much, or how do you feel about the trade-offs there?
Yes, it definitely does, but it would, even if we were doing it on a LAN. And the reason is, when you hit a bug, we have not yet come up with a great process for fixing that bug and continuing the playtest. So we've had too many times where we go to playtest and there is a bug that just blocks the playtest, or we start testing and we hit a really bad bug and we just call it, of like, thanks everyone, you're done. And so it really hurts design's ability to get feedback. It really hurts, all the downstream. It's something I plan on solving better than we have for dev. And it kind of reminds me is like, on Call of Duty 2, there was Ned. Ned was a designer. Ned would run the dedicated server on the LAN. And we would do a play test, and when there was a script error, the server would go down and we would all see that there was a script error. Ned would fix the script error and restart the server, and we'd play. So by the end of every playtest, the game was less buggy than it had been at the start of the playtest. So playtests are a way for us to stabilize the game. And we're in like the exact opposite of that now, of like, well, there's a bug, call it. Like, we'll try making a new server build, and we can try in an hour, because it takes a while to distribute the server build. And I really want to get back to the idea of playtesting your game is a way to fix issues and not just to find them.
Mm-hmm. Yeah, that just takes me into the whole like dev cycle and dev loop and just like optimizing for that turnaround time. And yeah, it's a hard problem. And it's one of those things that I think from afar you can kind of be like, oh, if the build takes 20 minutes to package and ship versus 5, that's okay. It's roughly the same amount. But I feel like that ability to literally make close to real-time edits is pretty essential for dev loop. But I think online anything just makes that strictly harder by nature. Yeah.
Yeah, it's something I'm going to tackle, because I feel like it is such a healthy feeling that by the end of the playtest, everyone's like, yeah, this game's cool. Like, it runs well. It's really nice to play. And you also didn't have that wall of like, sorry, there's a bug. Like, no playtest today. Because no playtest today is like the most demoralizing thing you can tell the team. It's like, sorry, that game you're making is so broken, it's not even worth trying.
Yeah. So I guess, let's just dip into just a little bit about versioning. So, I usually think of it in 3 parts. You got game client, game server, and then backend, which is all the other stuff, and accounts and login matchmaking and all that jazz. So like, what do you think of in terms of best practices for coordinating like API revs and stuff? And again, thinking in terms of dev cycle or dev loop, like how do you make that fast, or at least what have you found useful? Again, I'm more accustomed to like being on a backend team or group, and then I've got like dedicated front-end engineers, so we're always like negotiating API design up front, but like, just how do you think about that?
So my process, as I've been going from, there is no server to not only is there a game server, but there's backend servers, is I basically have pushed things in the place where I can patch them the quickest. And so for our backend servers, we can push a patch live in seconds, right? And then our game servers takes, kind of an hour if we're gonna like roll out a new server build. It takes time for QA to sign off, and then we upload it and it gets distributed and all that. And then client builds are, God, it used to be 2 weeks and now it's a few days. But it's still like, we're talking like day, hour, minute. And so more and more, I've been treating the game servers like I used to treat the client. So the client in client server is kind of dumb. It should do whatever the server tells it to do and not ask any questions. And now I'm sort of moved into a model where the dedicated server is kind of dumb, and it should do whatever the backend tells it to do. And so we're just pushing all that logic up into the fastest to patch area. But that does mean that your game is kind of like a Swiss cheese of like handles to pull and settings of, I'm gonna turn this feature off or change the rate at which we do this thing. And so it's like, it's becoming weirder that your server is just like, there's 1,000 convars that you can change from the backend server, but you always have to like push that into your dedicated servers constantly to get them to behave how you want right now. And so when you're signing off on a dedicated server build, it kind of means less and less, right? Like, I'm gonna change it after it deploys. So like, sure, thanks QA for signing off on it, but it's gonna be different when it goes live. Is a bad pattern, it's not a good thing. But it is sort of a consequence of this, like, how can I patch if the game is broken or, you know, like there's a major problem to solve? And so the flip side here is that design settings don't tend to get treated that way. When it's a design problem, we make them bake a new build. And if it is a client script, they have to wait days to get their patch out. Whereas if it's like an engineering problem of like matchmaking's down, whatever, we can fix that right away. And that is also sort of a consequence of access, of like designers don't get to change the dedicated server code base and they don't get to change the backend. So they don't really have that same layer of like, hey, I would love it if this character's setting was on a convar so that we haven't tested it a whole lot and I might need to tweak it post-launch. But the loop here is like, let's say you ship a new character that has a bad design setting in it, or not necessarily bad, but like they want to change it. For 2 days, people get to play this character with a setting that design isn't happy about, and then you can get your patch out, and now this character feels different. It's clearly bad, especially if you're gonna monetize that character or it's a big thing that you're promoting. And so I think we're still kind of stuck in a bad process of figuring out how to accelerate patches and figuring out how to make it easier to fix problems in production quickly. The backend move solves some of it, but it doesn't solve all of it.
Yeah, that's something I've worked with, again, like more dedicated like gameplay engineers and trying to talk them through the dynamics of like, hey, we can patch, again, backend data really fast, but where is that boundary line? And I have some people like, hey, I just want to embed the entire like scripting model and actual behavior, and I get a little nervous about that. I'm like, that actually might deserve like a little cook time and baking it and, you know, patching it through the regular. But on the other hand, I'm like, you know, attack speed or just like core metrics. So I usually try to like help define a data model that says, here's the properties that would be valuable to be able to effectively instantly change, and here are the ones that probably are worth more soak time with the gameplay team and being able to really feel it and change it. So yeah, but it's definitely a dynamic. It's not like a yes, no, it's definitely on a sliding scale.
Now the sort of flip side of that is on Apex Legends, we built a system to hot patch our weapons in case we shipped with like a major problem, and we never once used it because QA couldn't test it. And so it was like, we had this thing, you can drop this block of text in and override some weapon setting, but QA is like, how do I know if it's there? How do I prove that it's on? How do I prove that it's safe? Because you're sure I could test it on these builds in dev, but you're gonna turn it on in our build in production. How do I know it's gonna be the same as what we tested in dev? So we had a lot of process problems there that meant that it was just a feature we built that just never actually got utilized, even though I'm sure there were weapon setting tweaks that design wanted to fix. And we always fixed it with, let's make a new server build, let's test that server build and push that out because we can prove that that's what they just tested.
Yeah, that's something, yeah, the versioning side of that I think is really critical regardless of where you're making that change, because like on the back end, it's not hard to write some web front end that's gonna change a database value, and that thing is like streamed into the game client or the game server. And the problem with that is like, if that's a person clicking a button in a web UI, you know, I was working at consulting with a smaller studio for a while, and that was how they managed their store catalog. And so it was like, and they had no facilities for versioning or stamping or exporting that. So like getting ready for prod was, please remember the last 1,000 button click edits to the web UI and apply those to the staging build for prod. And I think it was basically 100% failure rate where every single patch included the store is broken and then somebody goes and tweaks it. So that's something that we definitely try to think a lot about is like, hey, you can make nice tools for designers to edit, but you need to have a version stamp where it's like, hey, version 1, 2, 3 of the catalog is there, and I can promote that into prod, because otherwise you just don't have that visibility. And also you need the tool to inspect what version is actually deployed, because if it's on a back-end server somewhere that nobody has access to, then you kind of have the same visibility problem.
So on Titanfall 1, I built a playlist system that we used a lot. And I made the super cool JavaScript web page that would like check all the input and build the final file when you were done. And I was like, man, designers are gonna love this. They can't accidentally break the playlist file. It's gonna have all these cool features that I'm gonna build in. And as soon as I turned it on, what happened was people complained that old builds were broken. And that's because I didn't have the capability of going like, oh shit, you're gonna run Wednesday's build. Well, okay, that was on playlist 1000 and now we're on 1014. And so what I immediately had to change it to was it saves it to a file. You check that file into Perforce and that file is read off disk. And so a lot of the like live updates of the playlist were just like immediately thrown. I'd done all that work and then I just threw it all away because I hadn't thought about the versioning part.
Yeah. Ah, man, there's too many moving parts. That's what I've decided. Yeah, okay, so I think we're kind of heading into our home stretch, and I wanted to spend a little time on Apex, mostly because I feel like watching the kind of evolution from the Call of Duties into Titanfall and then Apex, like, is this, continual growth? I mean, Call of Duty is always like this online multiplayer first game, but again, we had like split screen local co-op to kind of full-blown server authoritative kind of matchmaking backend, like, I wouldn't call it modern, but like, again, from those lobby browser eras of like the clients just pulling down a list of stuff stored on the master server under the desk in the office to, we've got this kind of richer ecosystem. So like, what did you, I guess for you in terms of tech choice or adoption of new tools, and how did you approach kind of taking the next step forward to what I would call like server authoritative online multiplayer, or just, and that's backend plus game server, but I guess just, yeah.
Sure.
Especially for Apex.
So Titanfall 1 is where we kind of got the mechanics of it, right? Where we were running on Azure, and we had this really kind of meager backend service that we had started working on. And then Titanfall 2, we moved off Azure. And so that was where we started working with Multiplay, who are part of Unity now. And that was a really great experience. We went 1 year from whiteboarding how their server autoscaler should work of hybrid bare metal and cloud across multiple cloud hosts, whiteboarding that to shipping the Titanfall 2 tech test. And it was a really fun experience to get to like think about how I want it to work and design it with them. And they're a great bunch of people. So we kept using Multiplay for Apex. But of course the scale ended up being much higher. And it was a surprise to us. So when we were getting ready to launch Apex, the prediction was, I think we had like, was it 100,000 CCU? I got to call out Hoff over there. Me and Hoff are 2/3 of the online services team on Apex at launch. The other Mike isn't here today. But yeah, I think there was like 150,000 CCU is what they expected. And they thought after a month we might get to 10 million users because at that time, Fortnite, it was massive, and it was like, we're gonna launch a battle royale against Fortnite, and it's free. Like, being free is not gonna be the big differentiator. And instead, like, we had, this crazy growth that was really fun because we handled it, but it could have been not very fun. And so I think it was like second weekend, EA, I have to say what EA did. EA said we were well over 2 million concurrent on the weekend 2 after launch. And at that scale of 2 million, we have a battle royale, so people are hitting matchmaking over and over and over. And it was like, the average session length would be like 12 minutes. And so you're putting through like hundreds of players a second across tens of dedicated servers a second. So you really have to be able to like just launch servers just over and over and over for 4 hours straight without a hiccup. And so it was only because we had started that on Titanfall 1 and really made it work well on Titanfall 2 that it wasn't a new thing we had to test on Apex. If we had done Apex on game 2, it would have just been a disaster. It would have fallen over, absolutely. And so, yeah, there's some of it is like, don't depend on getting every tech bet right on every game you make, or at least build in ways to cover your ass until you can fix it. And also, I would recommend not having a launch like Apex. It's pretty brutal, and it doesn't really give you a chance to fix anything. So at the time, I was thinking like, wow, most of the people who will ever play this game will play the worst version of it. And I was wrong, because Apex is much bigger now than it ever was then. But when you have everyone jump in right there, and it's like, design has never played a match in production yet to see like how it feels and whether they want to tweak anything. But that's what most people will see, and if they churn out in under 2 weeks, that's it. That's the version of the game they're going to get. But it was such a fun launch because we had spent the years building that backend that could handle that scale. And there's a lot of things we could talk about on my theory for designing backends. We can do that in Q&A though.
Yeah, let's open the floor for some Q&A, and then we'll do our breakout session so you guys can track them down and ask for the architectural diagrams. We'll have to find a whiteboard somewhere and do a little class. But yeah, let's open the floor.
Great talk. As you were talking about the moving things to the back end as opposed to the server and the game client, how are you thinking about business logic and duplication? Are you authoring those in different languages? C++ on the game server and Java on the services side, or what have you? How are you thinking about where does this logic need to live?
So the answer is it depends, which I know sucks. So yes, our game servers are C++, our game clients are C++, our backend is not C++. So we had a hybrid of PHP, which I like, and Lua, which scales a lot higher. And so we were doing Lua on Nginx with Redis, is the sort of the secret of how the backend scales so high on Apex. And then the PHP does not scale that high. So yes, you cannot share code between those two, or those three. And then we ended up trying to front run all the calls. And so when I say that, what I mean is Strider was the name for the backend, or is the name for the backend. And so like if we wanted to call a MTX server to find out like what does this player own, we would have the game server call Strider. Strider would call into the backend to find out what does this player own, and then it would return the answer. And so we ended up creating extra hops because of that. And the reason was, when the MTX server goes down, other Mike added in something, so it would just say, they own everything. And so when Apex was scaling up, the MTX server would sometimes, they were scaling up like crazy too. And sometimes it went down, and for the player experience, it was, oh, those guys unlocked all the characters for me. This is really cool, I get to try out all the characters. And then when the server came back online, we would take out our hack, and it would go back to getting the real answer of what does this player own. And so from a player experience, it was so great that they were like, oh, that was really cool. They let us try out all these characters that I haven't bought yet. Maybe I'll go buy them now. And so, yeah, everyone gets to retroactively go like, that was a really good business decision we made, instead of those are engineers trying to keep the game running. And so for things like that, I think it's always good to like, again, build in an oh shit handle to pull of like, if this service goes down, what am I gonna do? Can I turn that off? Can I turn off online friends? Can I turn off parties? And then when we get all that stuff working again, I'll send the command to turn them back on again, and we'll DDoS ourselves, and it'll be great.
Yeah, actually, I want to riff on that. Like, there's two really interesting points that jump out there, and both kind of from some League of Legends history, which is, it's a pretty like now famous story, so maybe most folks have heard, but they had to basically rebuild the store on launch of League of Legends because they had contracted out to an external team. Turns out it scaled to like 100 users or something like that. It like just didn't work. Literally could not function. So what the team had to decide then was like, what are we going to do about it? Because the game was launching, and they basically just opened the catalog up for that first, I don't remember if it was a month or longer, maybe Dinka remembers. Yeah, but it turns out that what it does is it creates the entire community conversation is about the game. And granted, like League was coming out when I think free-to-play, is pretty present in mobile, but it wasn't as common a technique as it was. But as you look at games trying to ship now, I mean, it's hard when your studio's like got budget and you have to like keep lights on. But you look at the conversation around monetization strategies, and you think about, okay, if I'm looking for my 10 out of 10, Steam reviews, and you're just thinking about how much conversation is going to stop being about your game and start being about how you're trying to sell the product to your players. And it's just a hard thing to navigate. So one of the things that I've generally started kind of pushing on studios is like, hey, maybe if you really believe in this game, you can be more generous with players and look for creative ways to invite only conversation about the game and kind of try to avoid some of those traps. Like imagine you're at a 6 out of 10 or something, and half of the negative reviews are people worried about or complaining about or accusing you of not doing monetization right. It's like, that's the difference between a mixed score and an 8 out of 10, which is gonna be like a very positive or something like that, so. And my other little quick one was same exact question we had to ask on checking. So League grew into this monstrosity of too many microservices, and the graph was fully connected, and like the literal diagram was just a black ball of lines. But we had to answer the same question if we were trying to check your kind of like, your ban status, are you allowed to play status? And you have the same problem of like, that's a remote network call, and that can fail. So the question is like, do you just ban everyone, or do you let them all in? And we talked it through, and we basically settled on the same idea of like, let the players play. If they're banned, one, it would be hard for them to be in the situation that they're in that moment at that time. Obviously the check's there for a reason, but fact of the matter is, if they're not supposed to be playing, they're gonna get kicked the next time because the network call is gonna fail. So just like defaulting to the player positive experience. Again, it's like actually the servers are failing, but from the player experience, they're just like, this is great.
So your actual question is about data storage, which I didn't answer directly. And I basically think unless the lawyers prevent you, it's always smart to keep copies of data that you pull from services. And for really practical cases of like, if we have 2 million players hitting matchmaking every 12 minutes, and it would be really nice to know which of them are friends with each other, I cannot call that per player. And so like, I really need to have a database that has that locally, that I can do a set intersection or whatever, however I want to solve it. But as soon as it's like in Xbox, they have a pass in 2 players and ask, are their friends? Like, you're gonna go n squared on 2 million players is gonna be really exciting. And so like, a lot of these are built with the expectation that you're not gonna have a local copy. And I think they haven't really had to ship a game and seen like how that impacts your backend design. Of if I have no idea who's friends with who, how will I design a social service? How will I design clans? How will I design any of these things? And I feel like the technical best case, maybe not the legal, is you have to copy that data and store it in a database and then try to synchronize it, which is just a big pain in the ass.
You also asked about the whole like, where does the logic live? And again, I don't think there's a hard and fast rule. They said it depends. But what I will say is the kinds of lines I think through are like, which are core gameplay logic, and I strive to keep that on the game side as much as possible. But you get into things like drop tables or loot tables or like enemy, like kind of those kinds of problems can oftentimes be well modeled on the back end. And again, the back end has the benefit that you don't go through cert, you don't have to patch a client. So there's a lot of niceties to kind of keeping that logic. So it's always that judgment call. But for me, anything on those kind of either metagame services, outside a game, obviously, but even like in-game, if it's more about data modeling and kind of content management, those kinds of problems I find tend to live pretty comfortably on the back end. But you still have to work out, like, can the designers edit those and how friendly are the tools?
I got a mic over here. Hey. Oh, hello. One of the things I'm always curious about when launching a game is worrying about scale. And so when Apex was launching and talking about, oh yeah, we're going to get 100,000 players or we're going to get some amount of players, it was interesting the conversations leading up to that where it was, what should we test to? And the joke that was going around EA at the time was it should be 6 million. And everybody's sort of scoffing at that, laughing at that, and then you look back at it now and it's like, actually it's good that we tested 6 million because it did actually get a high scale of CCU. So sort of maybe some feedback or comments about testing at scale and breaking your game pretty much to see how well you could actually run.
Yeah, that's a good one. The 6 million was for me. And that was, I saw a pattern forming with EA. Like, we did everything our own way at Respawn, and that was really different from how most EA studios ran. It was really hard for them to wrap their heads around, and it was really culturally different. And so there's a thing I could see coming where they're like, well, we think it's 150,000. You'll have to test to prove that you can handle 150,000. And at the same time, like Apex was a surprise launch. Like there was literally zero data to work off of what's the expected CCU. No one had heard about the game. And so I could immediately see as soon as I tested 150, they were going to go, oh, the new number just came in, and we think, now it's going to be 170. So I need you to go retest. And so to get ahead of it, I was like, why don't we just test 2 million per platform? Again, we had built Strider to handle pretty high scale. At least we had a plan for how you would spin up more servers and it would scale up. And so it was a sort of like, how do I get back to making a game and make EA leave me alone? And it was, okay, I will test my stuff to scale up to 6 million. And when you guys are done testing your stuff to handle 6 million, we can talk over if we want to go higher. And so that was where it came from, was sort of an idea of like, I know it's going to scale. Testing to 150 doesn't really add any value to me. Testing it to 2 million would be interesting because we see where it breaks. And once we know where it breaks, we can go figure out like how we would handle that and what we would turn off until we spun up more servers. But in the end, yes, I look like this wise sage of like, no, this game is going to be huge. But in reality, it was a very practical, like, testing to 150 is going to be step one, and I don't want to have to keep doing this over and over and over, and then people are going to be mad about how much it costs to test these scale tests every time. So let's just do it once, test it beyond what we think we need, and we'll see how close we get.
Awesome. I think that's just about time. So let's call it here. Thanks, John, for sharing, and yeah, super fun.